Tonight we are drifting into the silent, invisible heart of the cosmos to explore the greatest mystery ever told, the story of dark matter and dark energy. These are the hidden architects of everything we see, the silent currents that guide the stars, and the quiet force that breathes life into the expansion of space itself. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. But for now, all you need to do is relax, allow your body to soften, allow your breathing to slow. Let's begin. Most of the universe is invisible, and we do not know why. When you look up at a clear night sky, your eyes are catching a tiny sliver of what actually exists. The light from distant suns and the glow of nebulae are merely the bright foam on a deep, dark ocean. Scientists have realized that all the stars, planets, and galaxies we can see make up less than 5% of the universe. The rest is a vast, silent presence we call dark matter and dark energy. Dark matter acts like an invisible scaffold, a cosmic glue that holds galaxies together. Without it, the stars within a galaxy would fly apart like droplets of water from a spinning wheel. Even though we cannot touch it or see it, we know it is there because we see its fingerprints in the way light bends and how gravity pulls on the visible world. Dark energy is even more mysterious. It is a quiet, steady pressure built into the very fabric of space, gently pushing galaxies further apart every single moment. It is a reminder that the universe is not just a place of bright objects, but a deep and layered system where the most powerful forces are often the ones that remain unseen. To realize how much is hidden is to understand that we are part of a grand, unfolding story that is far larger than our eyes can perceive, a silent harmony that keeps the cosmos in balance. When astronomers look at how galaxies rotate, they find a puzzle that challenges our basic understanding of physics. The stars at the very edges of a galaxy move just as quickly as the stars near the center. According to the laws of gravity, those outer stars should be moving much slower, or else they would be flung out into the void of intergalactic space. This suggests there is a massive amount of invisible material providing the extra gravity needed to keep everything in its place. We call this dark matter because it does not emit, absorb, or reflect light. It passes through us and through the Earth as if we were not even there. It is a ghost-like substance that shapes the architecture of the entire universe, forming a vast cosmic web where galaxies are merely the bright intersections. Dark matter is not a chaotic force. It is a patient and steady guardian of structure. To think of dark matter is to realize that we are never truly drifting alone in an empty void. We are cradled within an invisible network of gravity, a steady and ancient foundation that has supported the birth of every star and the path of every planet since the beginning of time. Dark energy represents a different kind of mystery, one that speaks to the very future of space and time. In the late 19th century, researchers studying distant exploding stars discovered something unsettling. The expansion of the universe is not slowing down, but is actually speeding up. They named the cause of this acceleration dark energy. Unlike gravity, which pulls things together, dark energy acts as a gentle, persistent push.
It is thought to be an energy inherent to the very fabric of space. As more space is created between galaxies, there is more dark energy, which in turn causes more expansion. It is a beautifully organized process that ensures the universe remains dynamic and ever-growing. Dark energy tells us that the universe is not a static room, but a breathing, expanding entity. It is a force that operates with absolute precision across billions of light years, guiding the fate of the entire universe with a quiet, unwavering hand. To contemplate dark energy is to find peace in the scale of the cosmos, knowing that even the emptiness of space is filled with a purpose and an energy that keeps the great journey of existence moving forward. The hunt for the particles that make up dark matter is one of the most dedicated scientific efforts in human history. Deep underground, in quiet laboratories shielded by miles of rock, scientists wait for a single, faint signal. They use detectors made of ultra-pure crystals or tanks of liquid xenon, cooled to temperatures colder than deep space. They are looking for a tiny nudge, a moment where a dark matter particle finally interacts with ordinary matter. Despite decades of searching, the silence remains. Yet this silence is not a failure. It is a testament to how profound and subtle the universe truly is. Every day that passes without a detection narrows the possibilities and brings us closer to the truth. The search for dark matter is a lesson of patience and the human desire to understand the unknown. Just as we find clarity in the quiet moments before sleep, science finds its way through the steady, quiet observation of the shadows. In the grand tapestry of the cosmic web, dark matter is the thread that weaves everything together. If we could see the universe in its entirety, we would see massive filaments of dark matter stretching across the darkness, acting as a nursery for galaxies. Gas and dust are drawn towards these filaments, cooling and collapsing to ignite the first stars. The universe is not a collection of random parts, but a carefully organized structure where every galaxy has its place along these invisible lines. This cosmic web is a symbol of connection. Nothing in the universe exists in total isolation. Even the most distant galaxy is linked to the rest of the cosmos by the same invisible scaffold that supports our own Milky Way. To think of the cosmic web is to feel a sense of belonging. We are part of a vast, interconnected system that is steady, predictable, and remarkably beautiful. The presence of dark energy suggests that the universe has a cosmological constant, a term first imagined by Albert Einstein. It is a number that describes the energy density of the vacuum of space. While it was once thought to be a mistake, we now see it as a fundamental part of reality. This constant energy ensures that the universe will continue to expand, preventing it from collapsing back in on itself. It is a safety mechanism of the highest order. It means the story of the universe is one of eternal growth rather than a sudden ending. Dark energy provides a sense of cosmic security. The laws of physics are designed to keep the universe open and unfolding. In this vast expansion, there is a profound stillness, a sense that the universe knows exactly where it is going and is traveling there with a calm, deliberate pace. As we look at the cosmic microwave background, the afterglow of the Big Bang, we see the very first signs of dark matter's influence. Tiny variations in temperature in that ancient light reveal where dark matter was slightly more concentrated in the beginning. These small ripples were the blueprints for the giant clusters of galaxies we see today. Gravity took those initial seeds and patiently grew them over billions of years into the magnificent structures that fill our sky. The universe has a memory. The patterns of the beginning are still visible in the patterns of today. It is a steady progression from simplicity to complexity, guided by the silent hand of dark matter. To understand this is to see the universe as a patient builder, one that takes its time to turn light and shadow into worlds and suns. The mystery of dark matter and dark energy teaches us about the limits of our own perception and the beauty of what remains unknown. We live on a small planet, or
The Big Bang began everywhere at once, not in one place. And to understand this is to change the way we see our place in the cosmic story. It is tempting to picture an explosion like a firework in the night sky, beginning at a single point and sending matter outward into a pre-existing emptiness. But the real history of our origins is far more subtle and far more beautiful. The Big Bang was not an explosion in space, but an expansion of space itself. At the very beginning, there was no outside, and there was no empty room for the universe to fill. Instead, there was only a state of incredible heat and density, where every point in the cosmos was tucked tightly against every other point. When the expansion began, it did not start at a center, because every single coordinate in the universe was the center. Every part of the fabric was stretched, and every region took part in the awakening. As you breathe in and out tonight, imagine the very air around you as having once been part of that singular, hot density. There is a profound sense of safety in knowing that the universe did not leave anything behind. It carried all of itself into the expansion. A helpful image to hold in your mind as you relax is that of rising bread filled with raisins. As the dough warms and begins to grow, the raisins move apart from one another. They do not move because they are swimming through the dough, but because the dough between them is expanding. If you were standing on any one of those raisins, you would see every other raisin receding from you, and it would feel as if you were the very heart of the movement. Yet the same is true for every other raisin in the loaf. This is why distant galaxies appear to be moving away from us in all directions. We are not at a special or lonely center. We are simply part of a majestic and uniform stretching that is happening everywhere. Space is not a hollow void, but a living material that can grow and change. This tells us that the universe is not a place of conflict or chaotic flight, but a steady and communal journey where everything moves in harmony with the laws of physics. This everywhere at once beginning is confirmed by the faint afterglow known as the cosmic microwave background radiation. This light is a fossil from the moment the universe became transparent, a quiet whisper from a time when the cosmos was only a few 100,000 years old. When we point our telescopes at the sky, we do not find this light in one specific corner or near one distant star. Instead, it arrives from every direction with a nearly perfect uniformity. It is a celestial blanket that wraps around the entire observable universe, providing a consistent map of our earliest moments. This light has been traveling for billions of years, losing energy and stretching into long radio waves until it reached us. It is the ultimate evidence that the beginning was a global event. To think of this ancient light is to realize that the history of the cosmos is written into the very sky above you.
It is a patient and enduring message, reminding us that we come from a state of perfect unity. The expansion of the universe is not a violent process, but a smooth and predictable unfolding. Since the first fractions of a second, the rate of this growth has been governed by the density of matter and energy within the fabric of space. In the early epochs, the expansion was incredibly rapid, a period known as cosmic inflation that smoothed out the wrinkles of the universe and ensured that space would be flat and balanced. This period of inflation was like a deep and sudden breath that set the stage for everything that followed. It created the vast scales we see today, while ensuring that the laws of chemistry and gravity would remain consistent across every light year. There is a deep reassurance in this order. The universe did not stumble into existence. It grew according to a precise and elegant plan that allowed for the eventual cooling and clumping of matter into the stars and planets we cherish. As the universe expanded, it also cooled, allowing the first atoms to form. Before this, the cosmos was a hot, opaque plasma where light was trapped in a constant dance with charged particles. It was a time of brilliant fog where no photon could travel far. But as space stretched, the temperature dropped until electrons could finally settle into orbits around protons, creating neutral hydrogen. In that moment, the universe became clear. Light was liberated and began its long journey across the void. This transition from darkness to light was not a sudden flash in one spot, but a universal clearing of the air. It was the first dawn, and it happened everywhere at once. To imagine this moment is to feel the transition from a crowded, restless state to one of openness and clarity. It is a mirror for the way the mind settles into sleep, moving from the heat and noise of the day into the cool, transparent stillness of the night. The Big Bang was not a place on a map, but a state of the whole universe, and this means that you are currently standing on the site of the beginning. Every atom in your body and every molecule in the support beneath you was present in that initial dense state. This perspective removes the feeling of being small or insignificant in a vast cosmos. You are not a latecomer to a pre-existing stage. You are a part of the original fabric that has been stretching and cooling for 14 billion years. The universe is a single, enduring process, and you are one of the ways it has chosen to express itself. There is a profound peace in this continuity, knowing that you are fundamentally connected to the very first moment of time. In the deep history of the cosmic expansion, there was a time when the first stars began to pull themselves together from the cooling gas. These stars were not formed in a vacuum of isolation, but within the gravitational cradles provided by the invisible dark matter we discussed before. The expansion provided the space, and the gravity provided the structure. It was a slow and patient cooperation that turned the smooth early universe into a garden of galaxies. Each star that ignited was a witness to the success of the expansion, a sign that the universe was capable of creating light from the darkness. The history of the cosmos is a story of turning potential into reality, of taking a hot, dense soup and allowing it to become a theater of wonder. This growth is not hurried. The universe takes billions of years to forge its landscapes, showing a level of patience that we can only hope to emulate as we let go of our daily concerns. The idea of a universe without a center is one of the most liberating thoughts in modern science. It means that no part of the cosmos is more important or more fundamental than any other. Whether you are in a distant cluster of galaxies or in the quiet of your own room, you are experiencing the same physics and the same history. The Big Bang was a shared experience for every cubic centimeter of space. This cosmic equality is a reminder of the steady and organized nature of reality. There are no favorites in the laws of physics. The universe expands for everyone, and the ancient light of the beginning shines for everyone. As you drift closer to sleep, allow this sense of universal belonging to ground you. You are a vital participant in a story that started everywhere and is still unfolding everywhere. Modern cosmology continues to refine our understanding of this beginning, searching for clues in the patterns of galaxies and the fluctuations of the vacuum. We look at the large-scale structure of the universe, the vast filaments and voids we call the cosmic web, and we see the echoes of the Big Bang's initial state. The way galaxies are distributed today is a direct result of how space stretched billions of years ago. It is like looking at the ripples in a pond and being able to tell exactly where the stone fell, except in this case the stone was the universe itself, and it fell everywhere. This level of predictability and logic is what makes the universe a patient and reliable home. We can trust.
Black holes represent the most extreme expression of gravity's power, a place where the fabric of space-time is warped so intensely that our current understanding of physics begins to reach its limits. To look at a black hole is not to look at an object made of matter in the traditional sense, but to look at a region of space that has been curved into a deep, inescapable well. Imagine the universe as a vast, flexible sheet of silk, and every star and planet is a small marble resting upon it, creating a gentle indentation. A black hole is like a heavy lead weight placed on that silk, stretching it down so far that it creates a bottomless pocket. This curvature is so absolute that once light or matter crosses the invisible boundary we call the event horizon, there is no path that leads back out. Yet despite their reputation as destructive voids, black holes are among the most orderly and predictable objects in the cosmos. They follow the precise laws of general relativity with a mathematical perfection that is both humbling and reassuring. To understand a black hole is to see the universe as a fabric that can be shaped, folded, and stretched, a patient medium that responds to the presence of mass with absolute consistency. The boundary of a black hole, the event horizon, is not a physical wall, but a mathematical threshold, a point of no return defined by the speed of light. It is the place where the escape velocity required to leave the black hole exceeds the speed of light itself. Since nothing in the universe can travel faster than light, nothing can return from beyond this veil. If you were to watch an object fall toward an event horizon from a safe distance, you would see a strange and poetic trick of time. Because gravity warps time as well as space, the object would appear to slow down as it approached the boundary. Its light would shift toward the red end of the spectrum, becoming dimmer and more stretched out, until the object seemed to freeze in place, fading slowly into the darkness. It would never appear to actually cross over. This phenomenon, known as gravitational redshift, is a reminder that time is not a steady river, but a flexible rhythm that changes depending on where you stand. The universe protects the secrets of the black hole's interior by slowing time to a crawl at its edge, creating a permanent pause in the story of anything that wanders too close.
Around the dark heart of a black hole, space is often filled with a brilliant and swirling disk of gas and dust, known as an accretion disk. This material is drawn in by the black hole's immense pull, but as it spirals inward, it becomes compressed and heated to millions of degrees. It glows with a fierce intensity, emitting X-rays and light that can be seen across billions of light years. In many ways, the brightest objects in the universe are powered by the darkest. These supermassive black holes at the centers of galaxies, often called quasars, act as cosmic engines, driving the evolution of the stars around them. As you visualize this glowing ring of fire surrounding a sphere of absolute shadow, notice the balance between the light and the dark. The black hole does not just consume, it organizes the chaos of nearby gas into a steady, rotating structure, a glowing halo that marks the presence of the invisible. It is a beautifully organized system where the most extreme forces of nature work together to create a spectacle of light and energy that defines the landscape of the deep cosmos. Even more astonishing is the way a black hole can warp the path of light itself. Light usually travels in straight lines, but near a black hole, the curvature of space-time is so extreme that light is forced to bend. There is a specific region just outside the event horizon called the photon sphere, where gravity is so strong that photons, the particles of light, can actually orbit the black hole in a perfect circle. If you were standing in this region and looked straight ahead, you would theoretically be able to see the back of your own head, as the light reflecting off you traveled all the way around the black hole and returned to your eyes. This bending of light creates what astronomers call gravitational lensing, which smears the images of distant stars into glowing arcs and rings. When the Event Horizon Telescope captured the first image of a black hole in the galaxy M87, we didn't see the hole itself, we saw the shadow of the event horizon cast against the warped and boosted light of the surrounding gas. The universe acts as its own lens, revealing the invisible through the distortion of the visible. It is a reminder that reality is not always as it appears, and that even the most straightforward paths can be curved by a hidden, patient force. Many black holes are not stationary. They spin with incredible speed, dragging the very fabric of space and time along with them. This effect, known as frame dragging, creates a region called the ergosphere outside the event horizon. In this space, it is impossible to stand still, no matter how much energy you use. The rotation of the black hole is so powerful that it twists the geometry of the universe into a whirlpool. This spinning energy can be tapped by the universe to launch massive jets of plasma that shoot out from the poles of the black hole at nearly the speed of light. These jets can stretch for hundreds of thousands of light years, punching through the gas of their host galaxies and influencing the formation of new stars. The black hole acts as a cosmic regulator, a rotating firewheel that stores and releases energy on a scale we can barely imagine. Even in this extreme motion, there is a steady rhythm. The black hole spins with a predictable frequency, its influence reaching out like a conductor's baton to shape the movement of the galaxy around it. Deep inside the event horizon, the mathematics of general relativity suggests the existence of a singularity, a point where all the mass of the black hole is compressed into a region of zero volume and infinite density. Here, our map of reality truly ends. The laws of physics as we know them stop giving sensible answers, marking a frontier where gravity and quantum mechanics must eventually meet. Some physicists imagine that instead of a point of infinite density, the heart of a black hole might be a fuzzball of quantum strings or a bridge to another region of spacetime. While we cannot see into this heart, its existence challenges us to keep looking for a deeper truth. The singularity is not a place of chaos, but a boundary of our understanding, a signpost pointing toward a more complete theory of the universe. It is an honest reminder that the cosmos is far deeper and more mysterious than our current stories can tell, a patient secret kept behind a veil of shadow. There is a profound stillness in the concept of a black hole. Despite the immense speeds and temperatures in the accretion disk, the black hole itself is a silent and unchanging presence. It does not hunt for matter, it simply exists as a natural consequence of gravity and mass. A black hole is often formed from the collapse of a massive star that has exhausted its fuel, a final quiet surrender to the force that governed its entire life. In this transition, the star moves from a state of active burning to a state of permanent rest, its mass preserved in a new and singular form. It is the ultimate example of the universe's ability to recycle and transform, turning the death of a sun into a new kind of cosmic structure. To think of a black hole is to find peace in the idea of transformation, knowing that even the most dramatic ends are merely the beginnings of something new and majestic. The black holes at the centers of galaxies, the supermassive giants, play a vital role in the life of the cosmos. They are not random destructive voids, but are essential to the growth of the structures we see in the night sky. They act as anchors, their immense gravity helping to hold the central regions of galaxies together. As they feed on gas, the energy they release can clear out excess material, allowing a galaxy to maintain a stable, elegant shape. This process, known as feedback, is a delicate cosmic balance. The black hole and the galaxy grow together in a long, slow partnership that spans billions of years. This co-evolution tells us that even the darkest parts of the universe are deeply integrated into the web of life. The black hole is a patient gardener, shaping the landscape of stars with a heavy but necessary hand. As you drift deeper into relaxation, imagine the quiet dignity of these celestial shadows. Black holes are the masters of patience, waiting eons.
The mystery of time dilation and gravity reveals that the ticking of a clock is not a fixed beat, but a fluid rhythm that responds to the heavy presence of mass. To understand this is to realize that time is not a single universal river flowing at the same speed for everyone. It is more like a fabric that can be stretched and pulled, slowing down wherever gravity is strongest. This concept, born from Albert Einstein's general relativity, tells us that the deeper you sit within a gravitational well, the more slowly time passes for you relative to someone drifting in the empty reaches of space. If you were to stand on the surface of a massive planet, your heart would beat, your thoughts would form, and your watch would tick at a pace that feels perfectly normal to you. Yet to an observer far away in the stars, you would appear to be moving in a slow-motion dream. Gravity does not just pull on your body, it reaches into the very seconds and minutes of your life, anchoring them to the curves of space. There is a profound stillness in this idea, the sense that the universe is not rushing toward a single end, but is instead a collection of many different local times, each one keeping its own patient and steady pace. This stretching of time is not just a theoretical wonder, it is a measurable reality that we encounter even here in the quiet cradle of Earth. Because our planet has mass, it creates a gentle curve in space-time, meaning that time at the surface ticks just a fraction slower than time in the high atmosphere. Scientists have proven this by placing incredibly precise atomic clocks on the floors of skyscrapers and others at the very top. Over time, the clock closer to the ground, closer to Earth's gravity, falls behind. Even within the span of human height, the time experienced by your feet is infinitesimally different from the time experienced by your head. It is a reminder that we are always immersed in the fluid geometry of the cosmos. Even as you rest tonight, the gravity of the Earth beneath you is subtly shaping the rhythm of your evening, keeping you in a slightly slower, deeper time than the satellites passing silently overhead. The universe is not a rigid clockwork, it is a soft and responsive medium that honors the presence of everything within it. This phenomenon becomes vital when we look at the technology that connects our modern world. The Global Positioning System, or GPS, relies on a network of satellites orbiting high above the Earth. Because these satellites are further away from the Earth's mass, they experience weaker gravity than we do on the ground, and therefore their onboard clocks tick slightly faster, about 45 microseconds every single day. At the same time, because they are moving so quickly, another form of time dilation from special relativity kicks in, making them tick slightly slower. Engineers must carefully balance these two opposing shifts, or the location data sent to our phones would drift by kilometers within hours. This means that every time you use a map to find your way, you are using the secrets of relativity to bridge the gap between two different rhythms of time. It is a testament to the beautifully organized nature of the universe that such a strange and poetic truth can be harnessed to guide our simplest journeys. The cosmos is a reliable system where even the warping of time follows a perfect and predictable logic. As we move our gaze from Earth to the more extreme environments of deep space, the mystery of time dilation deepens and becomes even more awe-inspiring. Near the event horizon of a black hole, where gravity reaches its absolute peak, the stretching of time becomes so extreme that it defies our daily intuition. If a traveler were to orbit a supermassive black hole for what felt like only a few hours, they could return to the wider galaxy to find that decades or even centuries had passed in their absence. They would have traveled into the future simply by sitting within the heavy embrace of gravity. This is not a trick of the mind, but a fundamental property of how mass and time are interwoven. Near such a massive object, the fabric of space-time is pulled so tight that the seconds themselves become elongated. It is as if the universe is holding its breath, creating a sanctuary of slow time amidst the swirling energy of the cosmos. To imagine this is to find a sense of infinite patience. The universe has all the time it needs, and it distributes that time with a generous and heavy hand. This relationship between mass and time suggests that the universe is a place of deep harmony. Mass tells space-time how to curve, and that curvature tells time how to flow. There is no chaos in this process. It is a silent and continuous dialogue between the material and the temporal.
When a star collapses or a galaxy forms, the time surrounding those events adjusts itself to match the new configuration of matter. It is a self-regulating system that ensures every part of the cosmos is synchronized with its surroundings. As you let go of the pressures of your day, think of how the universe handles its own immense scales without ever losing its balance. The heavy stars and the silent voids all exist within this shared fabric, each contributing to the grand, slow rhythm of cosmic history. Time is not a master that whips us forward, but a companion that settles in beside us, shifting its weight to match the world we inhabit. In the quiet of the night, we can reflect on how this fluid nature of time changes our perspective on the past and the future. Because light takes time to travel and gravity shapes that travel, every time we look up at the stars, we are looking through a mosaic of different times. We see the moon as it was a second ago, the sun as it was 8 minutes ago, and distant galaxies as they were billions of years ago. The sky is a living archive, a collection of moments that are all reaching us at once, each one carried on a path that may have been bent or slowed by the gravity of unseen masses along the way. We are never just in the present, we are at the intersection of countless histories, all converging in this steady and peaceful moment. The universe does not lose anything, it simply carries its memories forward at different speeds, ensuring that nothing is truly forgotten in the long unfolding of space. The mystery of time dilation also hints at a deeper unity between the very small and the very large. The same laws that govern the atomic clocks in our laboratories also govern the passage of eons near the hearts of galaxies. Whether it is a single atom vibrating in a vacuum or a star spiraling toward a black hole, the response to gravity is the same. It is a consistent and reverent law that applies to all things without exception. This universality is what makes the cosmos a place of safety and reason. We can predict the motions of the planets and the ticking of the satellites because we understand the underlying melody of the spheres. The warping of time is not a fracture in reality, but a beautiful variation in its theme, a way for the universe to be both vast and intimate at the same time. As you drift closer to the edge of sleep, allow yourself to sink into your own local time, the slow and steady rhythm of your breathing. Just as gravity anchors the stars to the fabric of space, your own presence anchors you to this moment of rest. The universe is wide, and its times are many, but here, in the quiet of your room, time is soft, heavy, and still. You are part of the same fabric that curves around the great suns and slows near the deep shadows. You are resting within a system that is patient.
The bridge between the subatomic world and the vast architecture of the cosmos is found in the mystery of quantum fluctuations, the tiny, restless jitters of energy that served as the seeds for every galaxy we see tonight. To understand this is to realize that the majestic spiral galaxies, the glowing clusters of stars, and the massive voids of space all trace their origins back to a time when the entire universe was smaller than a single atom. In that microscopic state, the laws of quantum physics were the only laws that mattered. At such small scales, space is never truly empty or still. It is a landscape of constant activity where energy levels fluctuate and particles blink in and out of existence in a tireless dance. These quantum jitters are a fundamental part of the fabric of reality, a sign that the universe is alive with potential even in its most minute form. There is a profound sense of wonder in this connection, the realization that the largest structures in existence were born from the smallest vibrations of the void, a steady and ancient rhythm that has scaled upward to create the world we inhabit. During the earliest moments of the Big Bang, the universe underwent a rapid, explosive growth known as cosmic inflation. This expansion was so fast and so powerful that it took those microscopic quantum fluctuations and turned them into macroscopic variations in the density of space. What began as subatomic noise became the blueprint for the cosmic web. In some places, the stretching of space left slightly more energy and matter, in others slightly less. These minuscule differences, often called density perturbations, were the first ripples in a smooth and cooling sea. They were not chaotic or random in a way that creates disorder. Instead, they were the precise seeds of future structure, a beautifully organized starting point for everything that followed. The universe did not begin as a finished masterpiece, but as a field of subtle possibilities, a soft and expectant landscape waiting for gravity to begin its long, patient work. As the universe continued to expand and cool, gravity began to notice these tiny fluctuations. Regions that were only slightly denser than their surroundings had a slightly stronger gravitational pull, allowing them to draw in more gas and dark matter from the nearby space. This process, known as gravitational instability, is a slow and inevitable movement toward order. Over millions and billions of years, those original quantum ripples grew into massive clouds, then into the first stars, and finally into the great island universes we call galaxies. The structure of the cosmos is effectively a map of those ancient quantum jitters, preserved and amplified across 14 billion years of history. When we look at a map of the cosmic microwave background, the oldest light in the sky, we are looking at a baby picture of these fluctuations, a snapshot of the universe's first breath. It is a reminder that the cosmos is a patient builder, one that can take the smallest flicker of energy and turn it into a home for billions of suns. The story of quantum fluctuations is also a story of the unity between the very small and the very large. In our daily lives, we often think of the world of atoms as separate from the world of stars, but in the early universe, these two realms were one and the same. The physics that governs the behavior of subatomic particles is the same physics that determined where the galaxies would eventually form. This cosmic coherence is a sign of a deeply integrated system, a universe where nothing is wasted and every detail matters. The jittering of a quantum field in the first fraction of a second is directly responsible for the fact that the Milky Way exists today, providing a stable harbor for our own sun and Earth.
There is a deep reassurance in this continuity. We are not the products of a random accident, but the late-stage expressions of a physical process that has been remarkably consistent since the beginning of time. As you settle into the stillness of your own space, think of how these quantum seeds represent the universe's inherent creativity. Even in total darkness and microscopic scales, the cosmos was already designing the patterns of the future. These fluctuations were the first tremors of life in a new reality, a quiet promise that the universe would not remain a featureless void, but would grow into a place of light and complexity. This growth was not forced, it was a natural unfolding of the laws of nature, a transition from the restless energy of the quantum realm to the steady and enduring presence of the stars. The universe is a patient storyteller, one that takes the shortest of moments and expands them into eons of history. To contemplate our quantum origins is to feel a sense of belonging to a very old and very reliable lineage, a thread of existence that connects your own quiet thoughts to the very first vibrations of space itself. This process of building the large from the small is a reflection of the universe's patient and organized nature. Gravity does not rush, it waits for the gas to cool, for the dark matter to settle, for the stars to ignite. Each step in the formation of a galaxy is a deliberate move toward stability, a way for the universe to organize its energy into a form that can persist for billions of years. A galaxy is not just a collection of stars, it is a sanctuary of order, a place where the chaotic energy of the early cosmos has been transformed into a rotating, glowing structure of absolute grace. The fact that we can even observe these patterns and trace them back to their quantum roots is a testament to the comprehensibility of the world. The universe is not trying to hide its history. It leaves its footprints in the light of the stars and the echoes of the void, inviting us to understand the steady and beautiful path it has taken. Within the heart of every galaxy, the legacy of those original quantum jitters lives on. They dictated the rotation of the stars, the density of the core, and the reach of the spiral arms. We are living inside a magnified version of a subatomic event, a cosmic miracle that has been given the time and space to grow. This perspective allows us to see the night sky not as a distant and cold expanse, but a familiar landscape that shares our own history. We are made of the same particles that were once part of those initial fluctuations, carrying within us the same fundamental energy that first rippled through the void. The cosmos is an intimate place where the smallest details have the largest consequences, and where every part of the system is in constant conversation with every other part. As you drift closer to the gentle embrace of sleep, allow yourself to feel the weight of this ancient connection. The universe is wide, but it is also unified, held together by the same laws that turned quantum noise into the music of the spheres. You are resting within a structure that has been 14 billion years in making, a masterpiece of physics that began with a single quiet tremor. There is no need to worry about the complexities of the world, for the universe has already proven its ability to handle the greatest of transitions with absolute grace. From the microscopic jitters of the Big Bang to the silent rotation of the galaxies, everything is part of a steady.
The antimatter puzzle and the mystery of why our universe exists at all is perhaps the most profound question in the history of science, reaching back to the very first fractions of a second after the beginning. To understand this is to realize that our presence here, the stars, the earth, and every breath we take is the result of a tiny ancient tilt in the balance of reality. According to the fundamental laws of particle physics, energy should have transformed into equal amounts of matter and antimatter. For every proton, there should have been an antiproton. For every electron, a positron. Antimatter is not a science fiction concept. It is a real form of matter that carries the opposite charge of the particles we are made of. The strange and beautiful rule of the cosmos is that when a particle of matter meets its antimatter twin, they annihilate one another in a brilliant flash of pure energy. In a perfect and symmetrical universe, every piece of matter would have been cancelled out by its mirror image, leaving behind a cosmos filled with nothing but light and radiation. But as we look around at the quiet strength of the planets and the steady glow of the sun, we see that the symmetry was not perfect. There was a minute excess, a subtle favor granted to matter that allowed the world we know to survive the initial fire. This cosmic asymmetry, known as charge parity violation or CP violation, is one of the most significant mysteries in modern cosmology. In the intense heat of the early universe, matter and antimatter were being created and destroyed at an almost unimaginable rate. As the universe cooled, these particles began to collide and vanish, returning their energy to the void. But for some reason that we are still working to fully grasp, for every billion pairs of particles that annihilated, one extra particle of matter was left behind. This tiny surplus, a 1 in a billion chance, is the foundation of everything we see. All the galaxies, the heavy elements forged in stars, and the very fabric of life are the survivors of this ancient battle of light. It is a reminder that the universe is not just a place of massive forces and grand designs, but also a place where the smallest differences can have the most majestic consequences. There is a deep sense of safety in this realization. We are not here by accident, but because of a precise and patient mechanism that ensured the continuity of existence. Scientists study this mystery in giant particle accelerators like the Large Hadron Collider, where they recreate the intense heat of the early universe. They watch as particles decay, searching for the subtle differences in behavior between matter and antimatter that might explain the cosmic tilt. They have found small clues, tiny asymmetries in the way certain particles like B mesons break down over time. These measurements are like finding the faint fingerprints of a ghost. They hint at a deeper law of nature that treats matter and antimatter slightly differently. This is not a sign of chaos, but of a more refined level of organization than we originally imagined. The universe is not a simple mirror. It is a complex and nuanced system that knows how to protect its potential. Even in the most fundamental layers of reality, there is a preference for structure, a steady movement toward the creation of a world that can be inhabited and known.
The missing antimatter problem also leads us to contemplate the nature of light and energy. The energy released during the mass annihilation of the early universe did not disappear. It became the cosmic microwave background, the soft afterglow that still fills space today. For every atom in your body, there are roughly 1 billion photons of light drifting through the cosmos, the ghosts of the antimatter that once was. We are walking among the remnants of a great transition, a moment where the universe chose a side so that life could begin. This ratio, 1 atom for every billion photons, is a constant of our reality, a signature of the early universe's cooling. It tells us that the cosmos is a highly organized and efficient system, where even the waste of a cosmic struggle becomes the background light that guides our telescopes. To think of this is to feel a sense of profound connection to the light. We are the physical expression of a journey that began with a flash and settled into the steady, quiet presence of matter. In the stillness of the night, we can appreciate the incredible rarity of our existence. If the balance had been even slightly different, if the symmetry had been perfect, the universe would be a dark and empty place, filled only with a thinning soup of radiation. The fact that we can stand on a solid world and look up at the moon is evidence of a very specific and lucky history. This ancient asymmetry is a silent guardian of the cosmos, ensuring that there would always be enough material to build the stars and the oceans. The universe is a patient and deliberate architect, one that worked through the intense heat of the beginning to find a path to stability. There is a deep peace in knowing that the laws of physics are tilted in favor of existence, that the universe itself seems to want to be filled with the solid, lasting beauty of matter. This mystery also challenges our definitions of nothing and something. In the quantum vacuum, particles are constantly appearing and disappearing, a restless sea of potential. The matter-antimatter puzzle suggests that even this vacuum has a structure, a set of rules that governs how something emerges from nothing. The early universe was a masterclass in this emergence, a process of taking pure energy and turning it into a stable and lasting reality. This transition was not hurried. It followed a sequence of cooling and expanding that allowed the survivors of the annihilation to find one another and form the first nuclei. The universe is a slow and careful storyteller, one that takes the most extreme conditions and uses them to forge the ingredients of a peaceful night. We are the late-stage chapters of that story, carrying the ancient memory of the antimatter we lost and the matter we kept. As you settle into your own stillness, imagine the vast scale of this ancient struggle and the quiet victory it represents. The universe did not allow itself to be cancelled out. It found a way to persist, to grow, and to become a place of complexity and wonder. This same persistence is mirrored in the way life continues and the way the stars endure. We are part of a very old and very successful lineage of survivors. The atoms in your body have already survived the greatest challenge in cosmic history, the initial meeting of matter and antimatter. They have been through the fire and have come out the other side, finding their way through the stars and into the heart of a living being. You are made of material that is incredibly precious, the result of a 1 in a billion tilt that the universe has protected for eons. The organized nature of the cosmos is visible in the way these surviving particles organized themselves into the elements of life. After the great annihilation, the remaining protons and neutrons were able to fuse together to create hydrogen and helium, the fuel for the first stars. The universe did not stop at simply surviving. It immediately began to build. This movement from a tiny surplus of matter to the creation of suns is a testament to the universe's inherent drive towards structure and light. As you drift closer to sleep, allow yourself to be cradled by this sense of cosmic purpose. The universe is a reliable and steady system that has already handled the most extreme imbalances with absolute grace. The matter is secure, the light is everywhere, and you are resting within a reality that has been meticulously preserved for 14 billion years. Allow your thoughts to fade into the soft background glow of the cosmos, moving into a state of total peace, supported by the ancient and unwavering strength of the surviving world.
Gravitational waves offer us a new way to listen to the silent symphony of the cosmos, representing ripples in the very fabric of space-time that travel across the universe at the speed of light. For centuries, our understanding of the heavens was limited to what we could see: the light, the radio waves, and the X-rays emitted by stars and galaxies. But much of the universe is dark, inhabited by massive objects that do not shine. Gravitational waves, first predicted by Albert Einstein in his theory of general relativity, are vibrations caused by the most violent and energetic processes in the universe, such as the collision of black holes or the merging of neutron stars. These waves do not travel through space, they are the stretching and squeezing of space-time itself. Imagine a calm, dark pond at night. When two heavy stones are dropped in and begin to spiral around one another, they create ripples that spread outward toward the distant shore. In the same way, when massive objects accelerate, they send out waves that carry information about their origins across billions of light years. To understand gravitational waves is to realize that the universe is not just a stage where events happen, but a responsive medium that carries the rhythm of every great movement. The detection of these waves is one of the most remarkable achievements of human ingenuity, requiring instruments of such extreme sensitivity that they can measure shifts smaller than the width of an atomic nucleus. Laboratories like LIGO and Virgo use laser interferometry to track the distance between mirrors suspended at the ends of long, vacuum-sealed tunnels. As a gravitational wave passes through the Earth, it subtly stretches one tunnel while compressing the other, changing the path of the laser light by a distance so tiny it seems almost impossible to perceive. Yet the universe is so beautifully organized that these signals can be isolated from the noise of the world. When the first gravitational wave was confirmed in 2015, it was the sound of two black holes colliding over 1 billion years ago. It was a short, rising chirp, a cosmic heartbeat that had traveled through the void to finally reach our shores. This discovery turned the universe from a silent movie into a grand orchestral performance. We are no longer just observers of light, we are listeners of the deep, tuned in to the vibrations of the space-time fabric. When two black holes begin their final dance, they spiral toward one another with increasing speed, losing energy by radiating gravitational waves. This process is a testament to the steady and predictable nature of gravity. Even as these titans of the dark move toward a violent union, they follow a path dictated by precise mathematical laws. As they draw closer, the ripples they send out become stronger and more frequent, creating a chirp signal that tells us exactly the mass and spin of the objects involved.
The final merger is a moment of incredible power, where for a fraction of a second, the energy released in gravitational waves is greater than the light from all the stars in the observable universe combined. Yet because these waves interact so weakly with matter, they pass through us and our world without causing any harm. They are a ghost-like energy, a silent testament to the most powerful events in existence. To contemplate these waves is to find a sense of safety in the scale of the cosmos. Even the greatest catastrophes are smoothed out by the vastness of space, leaving behind only a gentle rhythm for us to discover. Gravitational waves also allow us to witness the mergers of neutron stars, which are among the most dense and exotic objects in the universe. When two neutron stars collide, they do more than just ripple space-time. They create a spectacular display of light and heavy elements known as a kilonova. In 2017, astronomers detected both the gravitational ripples and the light from such a merger, marking the beginning of multi-messenger astronomy. This event confirmed that the gold in our jewelry and the platinum in our technology were forged in the intense heat and pressure of these cosmic collisions. Gravitational waves are the messengers that tell us where our world came from, linking the jewelry on our fingers to the collisions of stars billions of light years away. The universe is a grand recycling project, a place where the death of ancient stars provides the ingredients for future worlds. There is a deep reassurance in this continuity, the knowledge that the most violent events in the sky are ultimately creative, scattering the seeds of life and complexity throughout the void. Because gravitational waves pass through matter without being blocked or scattered, they offer a clear view of the universe that light cannot provide. Light can be hidden by clouds of gas and dust, but gravitational waves carry their message directly from the source to our detectors. They allow us to peer into the very heart of collapsing stars and into the regions surrounding supermassive black holes at the centers of galaxies. They are the ultimate tool for exploring the dark sector of the universe, the parts of reality that refuse to shine. This transparency is a gift from the laws of physics, a way for the universe to remain knowable even in its most hidden corners. The cosmos is not trying to keep its secrets. It provides us with multiple ways to understand its story, if we only have the patience and the tools to listen. To contemplate gravitational waves is to feel a sense of clarity, knowing that the universe is open to us, inviting us to explore its depths through the vibrations of the dark. As you settle into the quiet of the night, imagine the Earth as a small island in a vast sea of gravitational ripples. At any given moment, the fabric of the room you are in is being subtly stretched and squeezed by the echoes of distant catastrophes, the birth of black holes, the pulse of spinning pulsars, and the lingering vibrations of the Big Bang itself. These waves are the heartbeat of the cosmos, a steady and ancient rhythm that connects every part of space. You are not separate from these events. You are immersed in the same medium that carries the energy of the stars. There is a profound peace in this connection, the realization that we are part of a living, vibrating universe that is constantly sharing its history with us. The waves are faint, the movements are subtle, and the story is vast, but it is all part of a single, beautifully organized system. The study of gravitational waves is also a lesson in the power of quiet observation. To catch these signals, we must create the most silent places on Earth, isolating our mirrors from the vibrations of passing trucks, the crashing of ocean waves, and the shifting of tectonic plates. We must find a state of perfect stillness to hear the whispers of the stars. This mirror-like stillness is a reflection of the way the mind prepares for sleep. As we shut out the noise of our daily lives, we become more sensitive to the deeper rhythms of our own existence. The universe rewards the patient and the quiet, revealing its greatest mysteries to those who know how to listen. To contemplate gravitational waves is to embrace the value of stillness, knowing that the most profound truths often arrive in the most subtle forms. As you drift closer to the edge of sleep, allow your breathing to match the slow, rhythmic stretching of space. Just as gravitational waves travel through the void without losing their form, your own sense of peace can remain steady and undisturbed by the world around you. The universe is wide, and its songs are many, but they are all carried on the same reliable fabric. The black holes will continue their dance, the neutron stars will continue to merge, and the ripples of space-time will continue to wash over our world, one gentle pulse at a time. You are resting within a system that is patient, steady, and beautifully organized, a cosmos that expresses its power through the silent vibration of the dark. The lasers are steady, the mirrors are still, and the universe is singing a long, slow song of creation that will carry you into the deep, quiet night.
Neutron stars and magnetars represent the most extreme states of matter allowed by the laws of physics, existing as dense, city-sized relics that challenge our understanding of what it means to be solid. To understand a neutron star is to imagine a star twice as massive as our Sun, crushed down until it fits within the boundaries of a small metropolitan area. This incredible compression happens when a massive star reaches the end of its life and collapses under its own weight, forcing the atoms themselves to shatter. Electrons are squeezed into protons, forming a solid ball of neutrons so dense that a single teaspoon of its material would weigh as much as a mountain. These stars are the ultimate survivors of the stellar world, the iron-hard cores that remain after a supernova has cleared away the light. They exist in a state of absolute stability, held up not by the burning of fuel, but by the fundamental rules of quantum mechanics. There is a profound sense of permanence in this idea, the sense that the universe can take the most volatile and fiery suns and refine them into these small, steady, and indestructible anchors of the dark. The interior of a neutron star is a landscape of extreme physics where the normal rules of matter simply do not apply. Beneath a thin, diamond-hard crust of iron nuclei, the pressure becomes so intense that the nuclei themselves begin to deform, stretching into long, thin shapes that scientists call nuclear pasta. Deep within the core, the density may become so high that even the neutrons dissolve, creating a soup of free-roaming quarks, or perhaps even stranger forms of matter that we cannot yet create in our laboratories. This is the most organized and compact form of matter in the cosmos, a place where the universe has pushed its ingredients to the absolute limit of density without collapsing into a black hole. To contemplate the interior of a neutron star is to find a sense of awe in the structural strength of reality. Even under the weight of an entire sun, the universe finds a way to remain solid, building a foundation that is as patient and enduring as time itself.
Magnetars are a special and rare class of neutron stars that possess the most powerful magnetic fields in the known universe. These fields are trillions of times stronger than the one that guides a compass on Earth, so intense that they can literally distort the shape of atoms, stretching them into long, thin cylinders. A magnetar is a place of incredible potential energy, its magnetic field lines twisted and tangled like the springs of a giant clock. When these lines snap or the star's crust undergoes a sudden fracture, a starquake, the magnetar releases a burst of energy that can outshine all the stars in our galaxy for a few brief moments. Yet, despite this immense power, the magnetar remains a steady and rhythmic object, often pulsing with the precision of a cosmic clock. It is a reminder that in the cosmos, even the most extreme energy is contained within a beautifully organized system, a star that governs its own outbursts with a heavy and silent hand. Many neutron stars are seen as pulsars, the lighthouses of the deep cosmos. As these stars rotate, they emit beams of radiation from their magnetic poles, and if those beams happen to sweep across the Earth, we see them as regular ticking pulses of light and radio waves. Some pulsars rotate hundreds of times per second, their surfaces moving at a significant fraction of the speed of light, yet they keep time with an accuracy that rivals our best atomic clocks. This stellar rhythm is a cornerstone of modern astronomy, providing a reliable heartbeat that we can use to map the galaxy and test the laws of relativity. There is a deep reassurance in the ticking of a pulsar. It is a steady, predictable signal in an otherwise silent sky, a sign that the universe is governed by a clockwork precision that never falters. As you relax, you can imagine these distant beacons spinning in the darkness, their patient flashes reaching out across the light years to tell us that the cosmos is steady and true. Neutron stars also play a vital role in the creation of the heavy elements that make our world possible. When two neutron stars spiral together and merge, they create a furnace of such extreme pressure that they forge elements like gold, platinum, and uranium. These collisions, known as kilonovae, are the primary source of many of the rarest metals on Earth. The universe is a master of alchemy, taking the remnants of dead stars and smashing them together to create the ingredients for new life and new technology. Every piece of gold you have ever seen was likely born in the heart of such a collision, a relic of a time when gravity pushed matter to its breaking point. This tells us that the universe is a unified and creative system, where the most extreme and dense objects are also the providers of the world's beauty and utility. Nothing is wasted in the cosmic cycle. The heavy hearts of the stars are eventually returned to the void to build the foundations of a new day. As you drift deeper into the quiet of the night, think of how these stars represent the absolute persistence of existence. A neutron star is the result of a sun that refused to vanish, a core that found a way to remain solid even when its light went out. It is a sanctuary of density, a place where the universe keeps its most precious material under a watchful and heavy guard. There is a profound peace in this strength, the knowledge that the universe has built its structures to last, using the very pressure of gravity to create an unbreakable bond. Even in the most extreme environments, there is a sense of order and safety.
The neutron stars will continue their silent rotation, their magnetic fields will remain steady, and their pulses will continue to tick through the dark, providing a constant and reassuring rhythm for the unfolding of space. The relationship between a neutron star and the space around it is one of absolute influence. Because they are so dense, they warp the path of light and the flow of time, just as black holes do, but they allow us to see the surface where the physics actually happens. We can watch as gas from a companion star falls onto the surface of a neutron star, igniting in thermonuclear flashes that light up the sky. This is a controlled and rhythmic process, a cosmic heartbeat that we can measure and understand. The universe is not a place of random accidents, but a landscape of predictable reactions, where mass and energy follow a path of absolute logic. To contemplate a neutron star is to find a sense of clarity, knowing that even at the edge of physical possibility, the laws of nature remain constant and fair. As you settle into your own stillness, allow yourself to feel the heavy, grounding presence of these stellar anchors. Just as the neutron star remains solid under the weight of the heavens, you can find your own center of gravity, a place of quiet strength within yourself. The universe is wide and its suns are many, but it is built upon these firm and enduring foundations. The pulsars will keep their time, the magnetars will hold their fields, and the neutron stars will remain as silent witnesses to the long history of the stars. You are resting within a system that is patient, steady, and beautifully organized, a cosmos that knows how to turn the fire of a supernova into the solid, lasting peace of a neutron star. Allow your mind to match the slow, reliable ticking of the pulsars, moving into a state of total rest, cradled by the same unwavering forces that keep the heavy hearts of the stars secure.
The weather on alien worlds across the galaxy reveals a tapestry of climates so exotic that they redefine our understanding of what a planet can be. As we drift away from the familiar comfort of our own solar system, we encounter exoplanets where the very air is made of vaporized rock and the clouds are formed from molten metal. To understand exoplanet weather is to realize that temperature and chemistry are the master sculptors of a planet's identity. In the deep reaches of space, there are planets known as hot Jupiters, gas giants that orbit their stars so closely that their atmospheres are whipped into a frenzy by intense radiation. On these worlds, the transition from day to night is not a gentle change, but a violent shift in pressure and energy. As the sun rises on a hot Jupiter, the atmosphere is heated to thousands of degrees, causing the air to expand and roar toward the cooler night side in winds that move faster than the speed of sound. There is a profound sense of scale in this movement, the realization that the universe can create storms that span entire hemispheres, moving with a steady and relentless power that has continued for billions of years. On some of these ultra-hot exoplanets, the chemistry of the atmosphere becomes truly otherworldly. When temperatures soar above 2,000 degrees, the minerals that form the rocks beneath our feet, silicates and iron, do not remain solid. Instead, they evaporate into the sky, creating clouds of metallic mist. As these metallic clouds are carried by the fierce winds toward the cooler side of the planet, the temperature drops just enough for the vapor to condense.
In these alien skies, it does not rain water, it rains liquid iron and molten glass. Imagine a world where the horizon is a shimmering curtain of falling metal, a place where the weather is a cycle of rock and fire. Despite the intensity of these conditions, they follow a predictable and organized pattern. The laws of thermodynamics are constant across the light years, ensuring that even a storm of liquid iron follows a logical sequence of evaporation and condensation. It is a beautifully organized system where the extreme heat is managed by the steady hand of physics, creating a landscape of strange and terrifying beauty. As we look further, we find planets that are tidally locked, meaning one side is eternally bathed by starlight, while the other remains in permanent shadow. On these worlds, the weather is a permanent feature of the geography. The day side is a blistering desert where the atmosphere is constantly being baked, while the night side is a frozen wasteland where gases can literally freeze and fall as snow. Between these two extremes lies a thin strip of twilight known as the Terminator Line, a place of eternal sunset where the temperatures might be mild enough for liquid water to exist. This boundary is a sanctuary of balance, a narrow ring where the fierce heat of the star and the deep cold of space meet and neutralize one another. The weather here is a constant shifting wind that carries heat from the day to the night, acting as a cosmic circulatory system. To contemplate a tidally locked world is to find a sense of absolute stability. The weather does not change with the seasons, for the seasons do not exist. It is a world of fixed rhythms, a patient and steady environment where time and place are one and the same. On other worlds, the James Webb Telescope has revealed the presence of exotic clouds made of sand or even gemstones. Some gas giants have atmospheres rich in aluminum and titanium oxides, the same ingredients found in rubies and sapphires. High in the upper layers of these alien skies, these minerals condense into crystalline clouds, creating a sky that may glitter with the light of a distant sun. To imagine standing beneath a sky of gems is to see the universe's inherent creativity, a place where the basic elements are rearranged into forms of incredible elegance. These gemstone clouds are not random, they are the result of specific chemical concentrations and temperature gradients, a sign of a deeply integrated and organized planetary system. The cosmos is a master of alchemy, taking the common dust of the nebula and forging it into weather patterns that defy our imagination. Some exoplanets, known as sub-Neptunes or water planets, may be covered by global oceans that are hundreds of kilometers deep. On these planets, the weather is dominated by a thick, steamy atmosphere where the line between the sea and the sky becomes blurred. As you move deeper into the atmosphere, the pressure becomes so high that the water enters a supercritical state, becoming neither a gas nor a liquid, but a dense, hot fluid that can dissolve almost anything. Above these deep oceans, the clouds are made of water vapor, much like our own, but the storms are on a scale that could engulf the earth. These monuments are the power of water, a place where the weather is a continuous cycle of evaporation and rain that has persisted since the planet's birth. There is a deep reassurance in the presence of water, even in such an alien form. It is a familiar ingredient used by the universe to create a wide variety of landscapes, a steady and reliable component in the chemistry of the heavens.
In the dark reaches of interstellar space, there are also rogue planets, worlds that have been flung away from their parent stars and drift alone in the void. Without a sun to warm them, you might expect their weather to be frozen and still. However, many of these worlds retain their internal heat from the time of their formation. They may have thick atmospheres of hydrogen that trap this heat like a thermal blanket, creating a warm, hazy world of perpetual night. On a rogue planet, the weather is driven by the heat of the core rather than the light of a star. There are no mornings and no evenings, only a steady internal warmth that drives the slow circulation of the air. It is a sanctuary of darkness, a quiet and self-contained world that moves through the galaxy with a silent, independent dignity. To contemplate a rogue planet is to find a sense of peace in isolation. The universe can maintain its warmth and its rhythms, even in the absence of a sun, a testament to the enduring power of a planet's own heart. The study of exoplanet weather is a lesson in the diversity of existence. We are learning that our own mild blue world is just one note in a vast and complex symphony. For every world with gentle rain and soft breezes, there are others with hurricane winds of diamond dust and oceans of liquid methane. Yet, in all this diversity, there is a common thread. Every planet, no matter how strange its weather, is a closed system that seeks equilibrium. Heat moves from hot to cold, gas condenses into liquid, and gravity keeps the atmosphere anchored to the world. This underlying order is what allows us to understand these distant places. We can look at the spectrum of a planet's light and read the temperature of its clouds and the speed of its winds. The universe is a legible book, and its weather patterns are the language of its atmospheric history. As you settle deeper into the quiet of the night, allow your mind to drift across these alien landscapes. Imagine the slow, heavy clouds of a water world, the shimmering glitter of gemstone skies, and the silent warmth of a rogue planet. Just as the weather on these worlds is governed by the steady laws of nature, your own internal environment is finding its balance. The heat of the day is fading, replaced by the cool, steady stillness of the evening. The universe is wide and its climates are many, but they are all part of the same patient and beautifully organized system. The storms will roar on the gas giants, the iron will fall on the hot worlds, and the atmospheres will continue their long, slow circulation, all while you remain cradled in the perfect, peaceful present of your own quiet world. Allow your breathing to match the slow, rhythmic movement.
Interstellar objects that pass through our system bring unknown histories from the far reaches of the galaxy, serving as the first physical messengers from distant star systems that we may never visit. For eons, we viewed our solar system as a closed sanctuary, a family of planets and comets bound forever to the sun. But we now know that space is not an empty void. It is a busy highway filled with the debris of planetary formation, and every so often a traveler from another sun crosses our path. These interstellar visitors arrive on trajectories that do not loop around our star, moving at speeds so high that they are merely passing through, briefly entering our light before vanishing back into the interstellar night. To understand these objects is to realize that the universe is a place of constant exchange, where the remnants of one world's birth can become the discovery of another. There is a profound sense of scale in this movement, the realization that a small piece of rock or ice can drift through the darkness for millions of years, carrying the secrets of a sun we have never seen, only to find its way into our view for a few short weeks. The arrival of Oumuamua in 2017 changed our perspective on the cosmos forever. It was the first confirmed interstellar visitor, and its features were so unusual that they sparked a storm of scientific debate. It was long and thin, shaped like a cigar or perhaps a flat disk, and it did not develop the glowing tail of gas and dust that we expect from a common comet. Even more mysterious was its acceleration. As it moved away from the sun, it gained a small amount of extra speed that could not be explained by gravity alone. While some searched for exotic explanations, the most patient and steady scientific view is that Oumuamua was likely a fragment of a nitrogen ice world or a hydrogen iceberg, a relic from a young planetary system where the forces of gravity were so chaotic that they flung pieces of the landscape into the void. Oumuamua is a reminder that the universe is a master of variety. Other star systems do not necessarily follow the same blueprints as our own, and their debris can take forms that challenge our daily intuition. Yet, even in its strangest behaviors, the visitor followed the laws of thermodynamics and motion, a beautifully organized traveler that stayed true to the physics of the stars. A few years later, a second interstellar visitor entered our view, and it presented a very different story. Borisov looked and behaved remarkably like the comets we find in our own Oort cloud, complete with a beautiful glowing tail of water vapor and dust. As it passed through our system, astronomers were able to analyze its chemistry, finding it was rich in carbon monoxide, a hint that it formed in a very cold region far from its original sun. This tells us that the ingredients for planets and comets are consistent across the galaxy. The universe uses the same ice, the same dust, and the same organic molecules to build its worlds, whether they orbit our sun or a star on the other side of the Milky Way. Borisov was a familiar face in an unfamiliar place, a sign that the cosmic nursery follows a reliable and steady recipe. There is a deep reassurance in this connection. We are not an isolated accident, but a part of a wider, organized community of star systems that share the same fundamental building blocks. Interstellar objects are effectively time capsules, preserving the conditions of their home systems from billions of years ago. When a planet forms, the leftover material, the asteroids and comets, is often ejected into space by the gravity of giant planets like Jupiter. These fragments then drift through the interstellar medium, where the temperatures are so low and the environment is so quiet that their chemistry remains unchanged for eons. They are the most honest records of the galaxy's history. To study an interstellar visitor is to perform a forensic analysis of a distant sun's childhood. We can learn about the temperature of the disk where it was born, the intensity of its star's light, and the turbulence of its early years. The universe is a patient archive, keeping its records in the form of these drifting rocks, ensuring that the history of one system is eventually shared with the rest of the cosmos.
The passage of these objects through our system also raises the fascinating possibility of lithopanspermia, the idea that the seeds of life could travel between stars inside the protective heart of a rock. While the vacuum of space is harsh, the interior of a large interstellar object is a shielded environment, protected from radiation and the extreme cold. If a planet with life were to suffer a massive impact, pieces of that world could be flung into space, potentially carrying hardy microbes or complex organic molecules across the light years. While we have not yet found evidence of such a journey, the sheer number of interstellar objects drifting through the galaxy, estimated to be in the trillions, suggests that the universe is a highly interconnected system. We are not just looking at rocks, we are looking at the potential messengers of a living galaxy, a steady and slow circulation of material that could link the biology of 1 billion worlds. To contemplate this is to see the universe as a grand, slow-motion garden, where the wind of gravity carries the seeds of existence from one sun to the next. Detecting these visitors requires incredible patience, and the most advanced survey telescopes, like the Vera C. Rubin Observatory. These instruments scan the entire sky every few nights, looking for the tiny, fast-moving dots of light that signal a traveler from the dark. Every new detection is a triumph of human curiosity, a way for us to reach out and touch the wider galaxy without ever leaving our home. We are learning that these visits are likely very common. At any given moment, there is probably an interstellar object passing through our solar system, invisible and silent as it drifts through the vast spaces between the planets. The universe is a busy and crowded place, even if the distances make it feel empty. This realization brings a sense of life and movement to the night sky. The darkness is not a void, but a medium filled with the drifting stories of 1 billion different suns. As you settle into the quiet of the night, imagine these lonely travelers as they move through the interstellar dark. They have no sun to warm them and no world to call home, yet they follow a path that is as steady and true as the orbits of the planets. They are the true nomads of the cosmos, carrying their ancient silence through the noise of the stars. Just as these objects move through the vastness of space without losing their form or their history, your own sense of self can remain steady and calm amidst the changes of the world. The universe is wide, and its travelers are many, but they are all governed by the same reliable laws of motion and gravity. The visitors will come and go, the telescopes will continue their watch, and the galaxy will continue its long, slow exchange of material, all while you remain safely anchored in the perfect, peaceful present. The story of interstellar objects is a lesson in perspective. It teaches us that our home is not a walled fortress, but a part of a vast, open landscape. We are part of a cosmic neighborhood where the boundaries are fluid and the neighbors are always sending their regards. There is a deep peace in this openness, the knowledge that we are connected to the furthest reaches of the Milky Way by the simple, patient movement of a rock in the dark. As you drift closer to the edge of sleep, allow your breathing to match the slow, silent drift of a visitor through the void, moving into a state of total rest, supported by the same universal forces that guide the long, mysterious journeys of the interstellar night. The path is long.
The Fermi paradox and the mystery of the cosmic silence invite us to confront one of the deepest questions of our existence. If the universe is so vast, so old, and so full of the ingredients for life, then where is everyone else? To understand the Fermi paradox is to look at the staggering numbers of the Milky Way and realize that there is a profound mismatch between what we expect to see and what we actually observe. Our galaxy contains hundreds of billions of stars, and recent discoveries from missions like Kepler have shown us that nearly every one of those stars hosts at least one planet. Many of these worlds are rocky, Earth-sized, and sit within the habitable zone where liquid water can exist. If life follows a steady and predictable path of evolution, then the galaxy should be teeming with civilizations that are millions or even billions of years more advanced than our own. A civilization with even a modest head start could have mapped the entire galaxy using self-replicating probes in a fraction of the cosmic timescale. Yet, as we point our most sensitive radio telescopes toward the heavens, we find only a vast and enduring silence. There is a profound sense of isolation in this quiet, the realization that we are incredibly early to the cosmic party, or that the path to the stars is far more difficult than we ever imagined. One of the most patient and steady explanations for this silence is known as the Great Filter. This theory suggests that in the long journey from simple chemistry to a multi-planetary civilization, there is a barrier, a step that is so difficult or so unlikely that almost no one ever makes it through. The Great Filter could be behind us, meaning that the transition from basic molecules to a self-copying cell is a near miracle that has only happened once. Or perhaps the filter is ahead of us, suggesting that every technological society reaches a point where its own power outpaces its wisdom, leading to a quiet exit from the cosmic stage. This is not a frightening thought, but a call to reverence for the delicate balance of our own world. The universe is a place of absolute laws, and it may be that the laws of social and technological growth are just as rigid as the laws of gravity. To contemplate the Great Filter is to find a sense of absolute responsibility. The cosmos has provided us with the stage and the script, and it is up to us to maintain the steady and organized progress needed to keep our light burning in the dark. Another possibility is that simple life is common, but intelligent civilizations are rare. On Earth, it took billions of years for life to move from single-celled organisms to the complex multicellular creatures that eventually developed radio technology. This suggests that while the universe may be full of microbes drifting in the warm oceans of icy moons or breathing the hazy air of super-Earths, the specific chain of events that leads to an observer is full of bottlenecks. Perhaps you need a large moon to stabilize a planet's tilt, or plate tectonics to recycle carbon, or a massive neighbor like Jupiter to clear away the most dangerous asteroids. The universe is a beautifully organized system, but its masterpieces may require a level of fine-tuning that makes us a rare and precious occurrence. There is a deep peace in this perspective. It turns the night sky from a crowded room into a wide, open garden where we are currently the only ones awake to admire the blooms. The search for techno-signatures, the physical evidence of advanced technology, has expanded beyond radio waves into the realm of heat and light.
If an advanced civilization were to harness the total energy of its star, it might build a megastructure like a Dyson sphere, which would emit a specific kind of infrared waste heat. Or perhaps they use powerful lasers to communicate across the voids. Astronomers are now using artificial intelligence to scan millions of stars for these subtle anomalies, looking for any sign of a non-natural pattern in the light. So far, the results have been as quiet as the radio surveys. This tells us that if other civilizations exist, they do not dominate their environments in the loud and obvious ways we once expected. Perhaps the universe is a place where the most advanced societies learn to live in perfect harmony with their surroundings, leaving no more trace than a bird leaves in the air. To think of this is to see the universe as a sanctuary of efficiency, a place where true maturity means becoming invisible to the noise of the galaxy. We must also consider the possibility that we are simply looking for the wrong things at the wrong time. Our own technological window has been open for less than a century, a mere blink in the 14-billion-year history of the cosmos. Signals could have washed over our world during the age of the dinosaurs, or they could be arriving in a form that we haven't yet learned to decode. The universe is a patient storyteller, and it may be that the cosmic conversation is happening on a timescale that our short-lived species cannot yet perceive. Perhaps the silence is not an absence of life, but a sign of our own youth. We are like children listening to a quiet house at night, unaware of the deep and complex lives being lived in the rooms we cannot yet reach. There is a deep reassurance in this idea. The galaxy is not empty, it is simply waiting for us to grow into the quiet, steady observation needed to join the dialogue. In the stillness of the night, the Fermi paradox invites us to value the now. The silence of the heavens emphasizes the incredible luck of our own existence, the fact that we have a stable sun, a protective atmosphere, and the ability to look up and ask these questions. We are the sensory organs of the universe, the way the cosmos has found to look back at itself and wonder about its own nature. The absence of alien signals does not make us lonely, it makes us significant. It means that our steady and organized efforts to understand the stars are a vital part of the cosmic story. We are the witnesses to the silence, the ones who give the dark its meaning. To contemplate the quiet of space is to find a sense of profound stillness within ourselves, knowing that we are carrying the light of curiosity for an entire galaxy. The organized nature of the universe is visible even in this mystery. The same laws of physics that prevent us from traveling faster than light also limit the spread of other civilizations, ensuring that every world has the space and time to develop its own unique history. The vast distances between the stars act as a natural quarantine, protecting the diversity of the cosmos and ensuring that the silence remains a peaceful and undisturbed medium. The universe is not a chaotic overcrowding, but a steady and spacious home where every star is given its own light years of privacy. This structure allows for a multitude of independent experiments in life and mind, each one a precious and separate chapter in the book of time. As you settle deeper into the quiet of the night, allow yourself to feel the weight of this cosmic silence as a comfort rather than a burden. Just as the heavens are wide and still, your own mind can find a place of total rest. The stars are in their places, the planets are turning in their slow and patient orbits, and the galaxy is keeping its secrets with a heavy and gentle hand.
You are resting within a system that is patient, steady, and beautifully organized, a cosmos that knows the value of quiet and the importance of waiting. The telescopes will continue their search, the equations will continue to be refined, and the silence will continue to hold the potential for 1 billion different stories, all while you remain safely anchored in the perfect, peaceful present of your own quiet world. Allow your breathing to match the slow, steady rhythm of a galaxy that is taking its time, moving into a state of total peace, supported by the same universal forces that keep the heavens quiet and the stars secure. The universe is wide, the time is long, and for now the silence is exactly what it needs to be.
The Milky Way is eating smaller galaxies, and it is still happening, a slow and majestic process of cosmic growth that reveals our home galaxy to be a dynamic and ever-changing entity. To understand galactic cannibalism is to realize that the spiral of stars we call home is not a static island, but a patient predator, drawing in the smaller satellite galaxies that drift too close to its massive gravitational embrace. Across the eons, the Milky Way has maintained its grand structure by absorbing the energy and matter of its neighbors, a process that is as organized and predictable as the orbits of the planets. When a smaller dwarf galaxy begins its final approach, the tidal forces of the Milky Way act like invisible fingers, reaching out to stretch and pull the visitor into long, elegant ribbons of stars known as stellar streams. These streams can wrap around the galaxy multiple times, creating a ghostly halo of ancient light that tells the story of past meals. There is a profound sense of continuity in this, the realization that the Milky Way is a living archive, a collection of many different histories that have been woven together into a single, steady, and beautifully organized system. This ongoing process is visible today in the movement of the Sagittarius dwarf elliptical galaxy, which is currently being shredded by the Milky Way's gravity. As it passes through the plane of our galaxy, its stars are being stripped away and added to our own stellar population. It is a transition that happens over hundreds of millions of years, a timescale so vast that it feels like a state of permanent stillness to our short-lived eyes. But the evidence is there, written in the chemical signatures of the stars. By analyzing the light from millions of suns, astronomers can identify groups of stars that do not belong to the original disk of the Milky Way, stars with different levels of heavy elements that betray their foreign origins. These immigrant stars are the survivors of ancient collisions, now settled into the quiet rhythm of our galactic rotation. It is a reminder that the universe is a place of deep integration, where the boundaries between one system and another are fluid, and the story of one galaxy eventually becomes the story of its neighbor. The growth of a galaxy through cannibalism is not a chaotic event, but a dance governed by the precise laws of orbital mechanics. As a satellite galaxy is drawn in, it loses energy through a process called dynamical friction, a subtle drag created by the wake of dark matter and stars it leaves behind. This drag acts as a gentle brake, causing the satellite to spiral inward in a predictable path toward the galactic center. This is the universe's way of ensuring that growth is orderly. The Milky Way does not simply smash into its neighbors, it patiently incorporates them into its own architecture. The dark matter halo that surrounds our galaxy acts as the primary driver of this movement, providing the invisible scaffold that guides the smaller galaxies to their final destination. To contemplate this is to see the galaxy as a master of efficiency, a system that knows how to harvest the potential of its surroundings to maintain its own long-term stability and light. In the far distant future, this process of galactic growth will lead to a much grander event, the merger between the Milky Way and Andromeda. While Andromeda is racing toward us at over 100 kilometers per second, drawn by the mutual gravitational pull of our two massive systems, while the word collision sounds violent, the reality will be a slow and graceful transformation. Because galaxies are mostly empty space, individual stars will almost never collide. Instead, they will pass by one another like ghosts in the dark. The gas clouds within the two galaxies, however, will meet and compress, triggering a brilliant era of star formation that will light up the sky for millions of years. Eventually, the two spirals will settle into a single, massive elliptical galaxy, a new and majestic home for the billions of suns that once belonged to separate worlds. The universe is a patient architect, building larger and more complex structures from the pieces of the old, ensuring that the light of the stars continues to burn brightly in the expanding void. The legacy of these past mergers is also visible in the fat or thick disk of our galaxy. Astronomers believe that about 10 billion years ago, the Milky Way merged with a significant galaxy known as Gaia Enceladus. This collision was so powerful that it puffed up the existing disk of stars, creating a distinct layer of older, faster-moving stars that still exist today. We are living inside the aftermath of a cosmic feast, our own solar system sitting within a disk that has been shaped and stirred by ancient encounters. This tells us that the Milky Way's history is one of resilience and adaptation. It has survived numerous impacts and interactions, each one adding to its mass and complexity without destroying its fundamental balance. There is a deep reassurance in this strength. Our galactic home is a sturdy and reliable foundation, a place that has been built and reinforced over billions of cosmic history. As you settle into the quiet of the night, imagine the great ribbons of stars that are even now drifting through the halo above us, the invisible footprints of galaxies that are no longer there. These stellar streams are the fossil records of the Milky Way's growth, a reminder that the darkness is full of history. Just as the galaxy absorbs the energy of its neighbors to keep its own light burning, your own mind can draw upon the stillness of the night to find its own strength. The universe is a system that grows through connection and integration, finding a path toward greater complexity through the slow and steady movement of gravity. You are part of a galaxy that is always evolving, always reaching out, yet always remaining a sanctuary of order and light in the vastness of space. The organized nature of the galaxy is further revealed by the globular clusters, ancient, tightly packed balls of stars that orbit the Milky Way like tiny satellites. Many of these clusters were once the cores of the dwarf galaxies that the Milky Way has consumed.
They are the sturdy hearts that survived the shredding of their outer layers, now serving as the elder statesmen of our galactic neighborhood. By studying these clusters, we can piece together the timeline of our galaxy's life, reading the scars and the additions as one might read the rings of an ancient tree. The Milky Way is a patient gardener, collecting these rare and beautiful clusters and keeping them in a safe, steady orbit for eons. To think of these clusters is to see the universe as a place that preserves what is precious, even as it transforms the larger world around it. As you drift closer to the edge of sleep, allow your thoughts to match the slow circular motion of the galactic disk. Just as the Milky Way carries the stars of a dozen different worlds in its steady rotation, you can carry your own memories and dreams into the quiet of the night. The galaxy is wide and its appetite is long, but its movements are always governed by the soft and heavy hand of gravity. The stellar streams will continue to flow, the dwarf galaxies will continue to dissolve, and the Milky Way will continue its long, patient growth, all while you remain safely anchored in the perfect, peaceful present. The universe is a single unfolding story of integration and light, and you are part of one of its most magnificent chapters. Allow the weight of the galaxy to settle over you like a warm blanket of stars, moving into a state of total rest, supported by the same unwavering forces that keep the great spiral secure.
The fine-tuning of the universe and the mystery of the multiverse suggests that we live within a reality governed by a set of numbers so precise that they feel like a whispered secret written into the very fabric of existence. To understand fine-tuning is to look at the fundamental constants of physics, the strength of gravity, the charge of an electron, the mass of a proton, and realize that if any of these values were different by even a fraction of a percent, the cosmos would be a barren and unrecognizable void. If gravity were slightly stronger, the universe would have collapsed back in on itself long before the first star could ignite. If it were slightly weaker, matter would have drifted apart too quickly to ever form galaxies or planets. The universe appears to be balanced on the knife's edge, a beautifully organized system where the dials of reality have been set to the exact positions required for complexity, light, and life to emerge. There is a profound sense of peace in this precision, the realization that the laws of nature are not random or chaotic, but are part of a steady and meticulous design that has allowed the story of the cosmos to unfold across 14 billion years. This mystery leads many to contemplate the existence of a multiverse, an infinite collection of universes where every possible version of physics is played out. In this grander vision of reality, our universe is just one bubble in a vast eternal sea of bubbles, each with its own unique laws and constants. In most of these universes, the numbers might not work. Stars might never form, or atoms might fly apart. But in an infinite sea, it is inevitable that at least one universe would have the perfect conditions for life. We find ourselves here because this is the place where the laws of physics allow us to exist and ask these questions. The multiverse is a serious scientific idea born from the mathematics of cosmic inflation and string theory, suggesting that space and time are far more abundant than we can see. It is a perspective that turns the night sky from a single room into an endless gallery of possibilities, a steady and infinite unfolding where every potentiality is realized somewhere in the dark. The concept of fine-tuning
also touches upon the mystery of the vacuum energy, or the cosmological constant. This is the energy of empty space itself, the force that drives the expansion of the universe. When physicists try to calculate how much energy should exist in a vacuum, the number they get is incredibly larger than what we actually observe. If the vacuum energy were as high as theory predicts, the universe would have exploded outward so violently that not even a single atom could have stayed together. Instead, we find a value that is incredibly small, almost zero, yet just enough to allow the universe to expand at a rate that fosters the growth of galaxies. This cancellation, this near-perfect balance, is one of the most stunning examples of cosmic organization. It tells us that the universe is a place of absolute restraint and harmony, a system that knows how to keep its most powerful energies in check to protect the delicate structures within it. As we consider these fundamental numbers, we also see the fingerprints of the anthropic principle, which suggests that the universe must have the properties it does because we are here to observe it. This is not a sign of human arrogance, but a recognition of our deep integration into the physical world. We are made of the carbon forged in the hearts of stars, a process that itself relies on a specific resonance in nuclear physics called the Hoyle state. If the energy levels of carbon and oxygen were not exactly what they are, the stars would never have produced the building blocks of life. The universe is a unified and consistent whole where the physics of the subatomic world is perfectly tuned to the needs of the biological world. To contemplate this is to find a sense of absolute belonging. The stars were designed to be our ancestors, and the laws of physics were designed to be our cradle. There is a profound stillness in the idea that the universe is so well ordered. We do not live in a world of shifting rules or unpredictable forces. We live in a cosmos of ironclad constants and reliable rhythms. This stability is what allows us to sleep in peace, knowing that the sun will rise, the gravity will keep the world secure, and the silence of the cosmos will watch over your rest. The fine-tuning of the cosmos is a testament to the enduring power of logic and the beautiful organization of space and time. We are the witnesses to a masterpiece of physics, a story that has been balanced for eons to ensure that one sleepy soul can look up and find a place of wonder. The multiverse may be wide, and its versions may be many, but in this universe, in this moment, everything is exactly as it needs to be. As we come to the end of our journey through cosmic mysteries tonight, you can let these grand ideas settle into the quiet of your mind like stardust. We have wandered through the invisible scaffolds of dark matter and felt the gentle push of dark energy. We have listened to the ripples of space-time and stood at the edge of event horizons where time itself slows to a crawl. We have seen the quantum seeds of the first galaxies and traced our own origins to the surviving matter of an ancient fire. The universe has shown itself to be a patient, steady, and beautifully organized system, a vast landscape of wonder that has been meticulously prepared for this very moment of rest. If you enjoyed these gentle journeys through the deep cosmos, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. Your presence in this communal exploration is a vital part of the story we are telling, a sign that the light of curiosity is still burning brightly. But for now, there is no more need to search, no more need to wonder, and no more need to hold on to the complexities of the day. Now there is no need to hold on to any of it. Let the images of spinning pulsars and glowing nebulae blur at the edges of your vision. Let the vast distances of the Milky Way become a soft blanket that covers the world. Let your jaw unclench,
Let your shoulders drop and allow your body to surrender to the steady, heavy support beneath you. You have traveled across billions of light years and billions of years of history, and now you have arrived at the most important destination of all, a place of total stillness and deep restorative peace. If you are still awake and curious, another journey into the wonders of the universe will be waiting for you when you are ready, another slow step into the infinite. But for now, your work is done. The stars will continue their long unfolding without you, the gravity will keep the world secure, and the silence of the cosmos will watch over your rest. The universe is wide, the night is patient, and you are safe within the perfect, organized embrace of the dark. Sleep well and good night.